Okay, now we're going to try and solve this differential equation. Okay, so we're trying to find a function of y as a function of x. Okay, so first thing, this is a type 1 differential equation. It's a first order differential equation because it's only got the first derivative of y in it. So it's a first order differential equation. And we should be able to rearrange this so it's in this form. dy dx equals some function of x. So let's try that. dy dx equals -1 over the square root of 9 minus 16x squared. Okay, now these are quite easy to solve. All we need to do is directly integrate this function. So we know that y is going to be the antiderivative of 9 minus 16x squared dx. Okay, so what's that antiderivative? Well, it kind of looks like inverse cos. So we could go, well, it's going to be 1/4 because we need a 4 on top there. So 1/4 of inverse cos of 4x on 3 plus c. Okay, so that's our y. Now we can find this c because we're given this boundary condition up here. Okay, so the boundary condition goes in to help us find what c is. So let's do that. So we've got 2 equals 1/4 inverse cos of 4/3 times x, and x is 3/4 plus c. Now this is 1. Inverse cos of 1 is 0. So we've got 1/4 cos. So we've got 1/4 of 0 plus c is 2. So therefore we've got 2 is equal to c. Okay. So now we've got the final answer. We've got y equals 1/4 inverse cos of 4/3 of x plus 2. There we go. Now I just want to show you something a little bit different. We could have done this in a different way using a definite integral to find our boundary condition or our c here in one go. Okay, so something a little bit different. So there's our thing. So we can go y equals, now this is how we do this. We go 2 is our boundary condition here. So we go 2 plus the definite integral, okay, x at the top, and our initial x value, so 3/4 down here, okay, of our, here we go, 1 over root 9 minus 16x squared dx. Okay, so by solving, oh, I've made a little mistake. I've got x in too many places here, so I'm going to change this to a dummy variable. I'm going to change it to t, just to, so when we can put in x as our upper limit here and replace t with x after. Okay, so now we've got 2 plus, now we're going to do this integral. We already know it's positive 1/4 of inverse cos of 4/3 of x, t, got to do it in terms of t, x 3/4. Okay, then we put in our top variable. Now it becomes back to x 1/4 inverse cos of 4x on 3. And then we put in 3/4 here minus what we get. So 1/4 inverse cos of, well, it ends up being 1. Put in 3/4 in there. This is 0. And therefore we end up back at what we had for x on 3, which is the same answer as what we had before. Okay, that's it.